Now, both dusts and flammable vapours, gases, can cause explosions, and this can be defined as the rapid flame propagation throughout an area containing dusts or flammable gases or vapours. Now, for an explosion to occur, there must be certain conditions there, and the most important is that that explosive material must be within the certain limits, basically the LEL and the UEL, which we covered here, the lower explosive limit and the upper explosive limit. It must be there for an explosion to occur. Now, explosions can occur in both unconfined spaces and confined spaces, and both of these can result in a loss of life, property and damage to the environment. Now, certain explosions occur with flammable dusts. Yeah, dust is a flammable. Dusts are flammable, some are anyway, and therefore there must be certain preconditions. So there's certain preconditions for a dust explosion to occur. And these preconditions are, firstly, the dust must be explodable. Not all dusts are capable of exploding. Certain ones are, like sugar, flour, starch. It must be capable of being airborne. It's got to be allowed to be airborne. The dust particles must be of a suitable size, and generally the smaller the better. And the whole idea is, if you can get a dust fine enough that it acts like a gas, because combustion is a vapour phase reaction, the closer you can get that dust to being small is more like basically a gas. The more violent it is, the more likely it is that it will explode. So it must be of a suitable size. It must be mixed within the explosive range. So in other words, dusts have flammable ranges, for example, between 5 to 12%. So you've got to have enough dust in the air to explode. And finally, there must be a sufficient source of ignition. So not all dust will explode with static, for example. So there must be the ignition source. Now, one of the worst dusts out there is Angel Delight. Strawberry flavour's the worst. Did you know if you've got some strawberry Angel Delight, put it in your hand, and you throw it in the air, and then you light a match, you will get, bang, an explosion. And you might lose your eyebrows. Now, don't try that at home, but that does work, Angel Delight. Now, in a dust explosion, generally what you'll get initially is what we call the primary explosion. And that primary explosion subsequently is followed by the secondary explosion, which actually causes the main damage to the building and structure. Primary explosions don't cause major damage, it's a secondary one. So what's the primary explosion then? Well, this will occur in the part of a plant causing localised damage to the lightweight plant, and generally you get pressures about 7 to 12 bar experienced. The problem is that primary explosion in the localised plant, as it explodes, it causes air disturbance due to a shock wave, and it basically disturbs any dust in the area, and it creates another cloud. So what you mean is the primary explosion is creating the conditions required for the secondary explosion. Did you know a 1 millimetre layer of dust, just 1 millimetre thick, can create a 5 metre deep cloud of dust which is capable of combustion? The secondary explosion, the dislodged dust gets airborne if it brings in those preconditions, and it's ignited by either the initial ignition source, which caused the primary, or another ignition source in that location. You get a secondary explosion. And that's what's causing the most damage. This shockwave generally blows out glass, doors. Primary explosions don't cause a problem, it's the secondary explosions. So how do you prevent a dust explosion? Well, if you look at the preconditions and remove one of them, that's what you do. Look at the preconditions and say, well, don't let that be there. So what are the preconditions? It must be explodable. Well, change the material. Now you change it. Don't go for a dust that's not flammable. But that's not easy, because generally you want flour to make bread. So you're not going to be able to do that. It must have been capable of being airborne. Well, don't. Get it down. Don't let it get airborne. It's the transfer mechanism. So try and keep it down using possibly a wetting agent. They must be of a suitable size. So use a process that does not produce such small particles. Again, that's not always relevant because it generally might have to be like that. It must be mixed with air within the explosive range. Well, don't let there be sufficient to get above the LEL. Try and get below, well below the LEL, and you won't have the explosive conditions. Ignition sources. They must have an ignition source. Basically, get the ignition sources out. Remove all ignition sources, so don't have them relevant. And again, like I said before, you could take outside the explosive range by, the main thing they do for dust explosions is good housekeeping. However, make sure it works. Dust extraction. I went to a company, I'm walking around with a manager, and they're telling me this area is prone to a dust explosion risk, and they've got good extraction and extraction in this area. And I'm looking around, and all the ledges, you can see the dust on all the ledges everywhere. And I said to him, have you got dust extraction in here? He says, yes, we have. I said, would you like me to get it fixed? Quite clearly, the dust extraction wasn't working. The whole area got at least a 3 mil layer of dust. Now, if there had been a primary explosion in that area, primary at the plant, it would have created a dust cloud in that area that would have took it all down. So if you've got this extraction, you make sure it's working. And finally, you can inert the area. So if you've got an explosive atmosphere, you can inert it, you can pump in nitrogen or something like that. This method basically attempts to increase the safety of, for example, a fuel tank or other sealed or closed-in tank that contains highly flammable materials or dusts. And what they're generally pumping is nitrogen, steam, CO2 or other gases. And the effect of these really is to try and eliminate the oxygen completely, or at least to make it below its LEL. So by inerting, you take the range, you narrow the range of the LEL. Basically, it takes it below the LEL. Now, if you watch this video now, it's going to show you how a dust explosion occurs. Now, this here is a dust explosion using lycopodium powder, and it's used in the movies. This is what they use to show explosions in the movies, and the reason they use it is because it's safer, because it can't go back down the pipe. Use it in dust explosions. It's a lot safer in the movies doing dust explosions than it is using, for example, LPG or other gases. That's why they use this lycopodium powder, and it's a dust explosion. Right, another option is to vent the explosion. In other words, let it blow, but vent it. So in other words, work out, we're going to let it go, but you create the weak point. You create the vent. You can direct it then where you want to go. In other words, where do you want to direct it? Up? Well, make that the vent. Make that the vent. You're creating the weak point. So that's venting. Alternatively, the plant can be designed to withstand the pressure from the explosion. So what they do is they'll work out what is the maximum explosive pressure from this particular gas or dust or whatever it is. They'll test and they'll say that this will create a pressure of 10 bar. Well, if you know it's going to get 10 bar and you can design the plant to take 12 bar, then even if an explosion does occur within there, it can take the impact, it can take the hit. So they can do that. However, generally it is usual to design it to vent. Rather than take the maximum explosion pressure, they will usually design equipment to take the vent. Why? Cost. It is very, very expensive to design equipment to take the maximum explosion pressure. It's too expensive. And the idea is you vent it to a height that the gases and ducts will be harmless. In other words, take it higher. Now, relief venting to reduce dust explosion pressures, which is what we're talking about, will still require the equipment to have a certain minimum strength. In other words, you can't just say make it of something that's only got 1 bar. An explosion the equipment still needs to take a certain minimum strength. So they might design to take 4 bar, but they'll put a pressure relief in. If it creates a 10 bar pressure, the 4 bar will take the hit, but the vent will then vent the explosion. So it does still have to take a certain minimum strength, which we worked out. Now this here shows you basically various methods of explosion relief. And it's all designed to release the pressure. You've got bursting panels, you've got vents, flame arresters, suppression control systems, as you can see on here. Now, bursting discs can be built into certain plant and machinery, and it's a designed weak spot that will burst when a predetermined pressure is received. So in other words, if they know it's going to go to a certain pressure inside the vessel, the bursting disc will burst at a very low pressure and release all the heat before it actually explodes. What's another option to all the things we've been covering now? Well, another option is to detect and then suppress the explosion. In other words, if you can detect the explosions happen quick enough, you may be able to suppress it and put it out. Now, the technique of explosion suppression involves the detection of a developing explosion at a very early stage and then extinguishing it before a destructive pressure is actually reached. Now, this can happen because just following explosion, there is a pressure wave. So when an explosion occurs, there is a pressure wave coming off that explosion before the flame front. Now, if this can be detected quick enough and a suppression agent can be set off before the destructive force of the flame gets there, you can put it out. Now, this shock wave can be detected by a very sensitive bit of equipment. And basically, if it can, then an explosion suppression system can go off. And this will normally consist of, first of all, you've got your explosion detector, you've got your control system which sets off the extinguishing agent, and you've got your suppressor unit. Now, that suppressor unit will use different materials to suppress an explosion. It's stored under pressure and it's released at very high speeds. Now, the choice of the suppressant material will depend on a number of factors. However, a good suppressant normally should have the following properties. First of all, it must have a good quenching ability. It must be able to absorb rapidly the heat from the combustion zone. So it must be able to absorb the heat. Dilution properties. The suppressant concentration in the unburnt mixture should have the effect of diluting it to a point where it becomes non-flammable. And wetting, especially if it's a liquid suppressant. The unburnt dust particles are rendered non-flammable by the absorption of liquid suppressant. So basically, absorbs a liquid suppressant, it becomes non-flammable. Now, this picture here shows you generally how an explosion suppression system works. You've got your explosion there, you'll have your pressure wave which will travel away, and it reaches the detector. Now, that detector might be able to detect an increase in pressure as low as 0.02 bar. And as soon as it picks up that pressure increase, it thinks, we've got an explosion. It sends a signal to the electrical power unit, and the suppressor, the quenching agent is set off immediately, the suppressor, and it puts out the fire before the explosion can get out of the zone. I mean, they do use either pressure increases, and you can also have flame detectors in some where it actually sees the flame and it sets off the suppressor. So there are other ways of detecting it, but the main one generally is by this pressure wave. Where are you going to get these explosion situations? You can get them during hot work. You can get explosions in crude oil tankers, small pleasure craft, garages, inspection pits. Now, the next issue I'm going to look at is what you can do to minimise the risk of a recurrent dust explosion. What can you do? Well, first of all, you can provide exhaust ventilation on your dust filters. You can enclose any open bag dust collecting filter units. You can ensure that seal joints on flour handling systems to prevent the escape of dust, so they're all sealed. All the joints, make sure they're all properly sealed. You can insulate hot surfaces, for example, by lagging the pipes. And you can ensure the surface temperature is kept below that required to cause ignition using safe electrical equipment and making sure you bond all metal work to earth. Make sure it's all bonded. You can ensure that regular maintenance of plant is carried out, and critically, ensure a high standard of housekeeping is maintained, including the use of vacuum cleaners to reduce to a minimum the accumulation of dust on high ledges and floors. I remember I went to a client, they had a dust explosion risk. I'm walking around the risk area and I said to the manager, have you got a dust extraction system in here? He said, yes, we have. I said, well, would you like me to get it fixed? Because everywhere you could see a layer of dust, all the ledges, and it was obviously not working. So don't just say we've got an extraction system, have a look at it. Does it work? Why is it a 5 mil? There was dust everywhere. It wasn't clearly working. They are the areas you can use to minimise the risk of recurrent dust explosions, and you should do them as part of your risk assessment.